The right shoulder of Orion is stirring up controversy once again. On the one hand, there is the theory that Betelgeuse is rotating much faster than it should because it once devoured another star, but on the other hand, there is the assumption that the stellar giant is still not alone. Even if Betelgeuse is a binary star, how come the companion star has not been found yet, and how would its existence directly lead to the solution of a fundamental mystery in our imagination? The Sun is frequently regarded as the ultimate object in the universe, which is understandable given that, in theory, our Earth would fit into our mighty mother star about 1.3 million times. However, even though the Sun, which has a diameter of nearly 1.4 million kilometers, can be considered impressive, we must remember that there are much larger celestial bodies out there that would reduce our central star to a tiny dust particle. A quick reality check brings us back to Earth in terms of astronomical facts, and we discover that Betelgeuse is superior to the Sun in every way. It is situated in the Orion constellation, approximately 650 light-years away from us, and has a diameter that is 800 times larger than that. This enormous disparity in size is also reflected in the luminosity of the Sun. In fact, Betelgeuse emits an invisible light that is 10,000 times brighter than our source of warmth and life, at least in theory. However, even in space research, the principle that exceptions validate the rule appears to apply. 5 years ago, Betelgeuse presented experts with a huge mystery when it dramatically lost brightness within a few weeks. In fact, the stellar dimming was so pronounced that it could even be seen with the naked eye in the night sky. In principle, periodic. Brightness fluctuations are quite normal for Betelgeuse, but in this case it darkened much faster and more intensely than usual. A brief aside, the astronomical unit of magnitude indicates the apparent brightness of a celestial body, and the smaller the magnitude value, the brighter the object appears to us, and while Betelgeuse with an average luminosity of 0.3 to 0. 4 magnitudes is actually one of the 6th to 7th brightest stars in the entire sky. In December 2019, it darkened to 1. 1289 magnitudes and consequently fell to the 21st place in the brightness table. Is Betelgeuse about to become a supernova? Consequently, the experts had to look for explanations for this unexpected development, and since Betelgeuse as a red supergiant is approaching the end of its stellar life. Anyway, the suspicion was briefly raised that its brightness drop was connected to an imminent supernova, and we remember when it's not experiencing a mysterious dimming, Betelgeuse already shines, 10,000 times brighter than the Sun. However, as soon as it bids farewell to the cosmic stage in a violent explosion, researchers expect it to experience a 16,000-fold increase in its current luminosity in the course of this Betelgeuse would reach an apparent brightness of 9.5 to 1. 5 magnitudes. Some experts believe that the celestial body will then appear as bright as the full moon, and it should even be easily recognizable during the day, but when exactly we can expect this radiant spectacle is a completely different question. In fact, most experts have now abandoned the assumption that the supernova will occur in the foreseeable future. What was at times interpreted as a harbinger of a primal spectacle turned out to be a massive plasma eruption in the course of follow-up observations. This in turn produced a no less massive dust cloud which darkened the star by almost 2/3 for our earthly eye, as mentioned earlier. Betelgeuse has reached the last stages of its life cycle and regularly loses large amounts of stellar material. This is transported to the surface by convection currents from the interior and ejected, but in the same breath, Betelgeuse also experiences 400-day cycles of expansion and contraction. And experts estimate that it was the combination of strong convection and expansion that caused the plasma eruption to be 2 to 3 times more intense than usual. And if we draw the bow back to the solar comparison at this point, we see that Betelgeuse is also ahead. This time, the rate of mass loss during this event was about 30 million times higher than for our Sun. The bottom line is that the ejected plasma is likely to have cooled in space and eventually condensed into a gigantic dust cloud. And since this happened to be in the line of sight between the Earth and the red supergiant, it appeared to us as a huge veil that apparently darkened the star. The rotation puzzle has: Betelgeuse devoured another star, but it wouldn't be Betelgeuse, without a few more mysteries for astronomers. For instance, pictures taken a few months ago by the ELMA Observatory's coupled radio telescopes revealed that it was rotating at an absurdly high speed for a red supergiant. In particular, the rotational speed was over 5 km/s, which is 50 times faster than what would be expected for a star of this spectral class. In this context, Betelgeuse completely flips the stellar scheme on its head. In this way, stars actually slow down as they expand. Betelgeuse is the only known red supergiant that is believed to rotate so rapidly, according to Jingsma of the Max Planck Institute for Astrophysics in Gering, Bavaria. More precisely, the bipolar structure of the surface is responsible for the corresponding speed, with one half displaying a blue shift and the other a red shift of several km per second. However, what explanations do astronomers have for this unexpected rotational behavior? Behavior, to say the least. Well, the first theory is based on the assumption that Betelgeuse is a cosmic cannibal. In other words, when it expanded into a supergiant around 100,000 years ago, it may have swallowed a companion star similar to the Sun. In this scenario, the absorption of so much Mk caused the swallowed star to transfer the angular momentum of its orbit to the outer shell of Betelgeuse, thus accelerating its rotation, and while this hypothesis was put to the test in a computer model, tangible evidence for it has also been collected images taken by the Herschel Space Telescope several years ago showed that two zones of ejected stellar material lied dormant on one side of the supergiant. In principle, these shell-shaped structures were interpreted as the harbingers of the approaching supernova explosion, but at the same time, they are located almost exactly at the distance at which they would be expected after a stellar cannibalism incident. And yet there are other possible explanations in this regard. Massive bubbles of rising and descending plasma decorate the star's surface, covering a significant portion of its visible outer shell, as seen by Ma's study team. This is exactly the crucial point, because the rapid movement of these plasma bubbles can also produce the aforementioned red and blue shift of the radio emission. In other words, it is possible that Betelgeuse is not actually rotating too fast, but rather that it's creating a kind of optical illusion if a very large convection bubble or a group of them is moving towards the observer and another is moving away from him at the same time. Even a star that is not rotating at all can appear to be rotating extremely fast, and indeed a recent analysis of the ALMA data in combination with an astrophysical model showed that this explanation is anything but far-fetched. On the contrary, according to MA, there is a 90% probability that the maps generated in the simulation will be incorrectly interpreted as high rotation rates. This is primarily due to the low resolution of the ALMA images, which distorts the true characteristics of the movements on the stellar surface. So, at present, it's not possible to say with absolute certainty how fast Betelgeuse really rotates and how likely the scenario of the swallowed star is. But what we can say is that the evidence is mounting that the red supergiant is not alone, after all does Betelgeuse have a companion star as mentioned earlier. The brightness and surface of Betelgeuse pulsate in a cycle of about 400 days. Well, actually, the red supergiant has still not recovered from the gigantic plasma eruption of 2019, and the reverberations of the eruption continue to create rapid oscillations in its interior while the surface is still vibrating like an oversized jelly according to astronomers. It will take several years before the star finds its way back to its normal rhythm. However, in addition to its 400-day pulsation, Betelgeuse also exhibits a secondary longer brightness fluctuation that occurs over a cycle of 2,170 days, or almost 6 years, but the reasons behind these long periodic fluctuations remained unclear for a long time, In order to finally change this, Jared Goldberg and his colleagues from the Flatiron Institute in New York recently dedicated themselves to the task of thoroughly re-examining all of the observational data on Betelgeuse. The new analysis did uncover several unexpected anomalies, starting with the fact that the long periodic fluctuations are shifted against the rhythmic pulsation beyond that, and the 6-year cycle in the star's light curve is subject to a different rhythm than the subtle 400-day pulsations. However, the experts were unable to detect any accompanying phenomena that would be linked to causes like rotation sequences, magnetic field effects, or convection currents. Ultimately, the experts came to the conclusion that there is only one potential explanation for the long-period oscillations that has no fundamental flaws, namely the existence of a smaller companion star. Conversely, the strange 6-year fluctuations would thus reflect the orbits of the companion star as soon as the stellar companion is behind Betelgeuse. As seen from Earth, the secondary period is at its lowest brightness. However, when the companion is next to Betelgeuse, the luminosities of the two celestial bodies combine and the brightness reaches its maximum. At the same time, the companion star could also act as a natural dust shifter, influencing the distribution of the dust clouds and thus playing an additional role in Betelgeuse's brightness changes. So far, so plausible. But how is it that the companion star has not been detected yet? Well, the answer to this question probably lies in its low mass. According to the researchers' calculations, it weighs only about 1.7 solar masses. Betelgeuse, on the other hand, has almost 20 solar masses. Furthermore, the companion star is likely to orbit its much larger partner quite closely at a distance of only 2.43 Betelgeuse Radi, to be precise, as a result of this configuration. The companion star is significantly outshone by its more imposing counterpart, and the brightness fluctuations and pulsation of Betelgeuse further complicate the task of detecting the companion's traces in the light curve, and even though the chances of spotting the companion star with today's telescopes are, to put it mildly, modest, the experts now want to apply for observation time at some of the large telescopes. In doing so, they hope to uncover further evidence of the stellar partner's existence and possibly even clarify what kind of star we are dealing with here. The kind of button you are interacting with in our film has been promptly addressed. Feel free to press the thumbs up button. And to remain updated going forward, subscribe today. We'll see you soon.